Well, hello, everyone. Welcome to the first of three press conferences here at ASA and ICA's joint meeting. Thank you, everyone, for coming here a little bright and early this morning. And welcome to any of our live stream viewers, members of the media, and colleagues who are watching from afar. So, to get started today, we're first going to hear from Marisha Spates about laying the groundwork to diagnose speech impairments in children with clinical AI. We are also going to hear from three other presenters today, and there will be opportunities for question and answer within the live stream. So if you type your questions into the chat, we'll be monitoring that, and after each presentation, we'll read some of them out. Recordings for the press conference will also be available after the fact, and we will make those available to any members of the media or people who are interested in them. Please email media@aip.org to receive those copies. We will also be giving them to anyone else who is also interested if someone wasn't able to make the recording and is interested in watching it later. All right, so I'm going to pull up the first presentation and hand it over. Welcome.
Good morning. Thank you so much for the opportunity to share about our work today, about how we're leveraging AI to build clinical applications to support early detection of speech and language impairment in young children. So let's start first with what is a communication disorder? So most children learn to use the sounds and words in their language quite easily. But for some children, this is quite challenging. And when they have difficulties, sometimes this requires for them to have speech therapy. So approximately 1.3 million children are impacted by communication disorders each year, but approximately 40% of those go undetected. And so why are we concerned about them going undetected? So children who face these kind of challenges are also susceptible to later learning difficulties, also social difficulties, and sometimes mental health difficulties as well. So we want to make sure that we identify these children as early as possible. There also, after the pandemic, we saw a large rise in the number of children who are having difficulty, specifically with speech development, which is what I will focus on more so in this talk that I share. So post-pandemic, we saw that this large spike in the number of children that were being identified, but this also comes at the cross-section of a time when we have a shortage of speech-language pathologists who provide services to support speech and language learning in children. So our traditional pathway for children to be identified is that someone in their realm finds that they're either having difficulty with the sounds in their language, so they're harder to understand, or they're having difficulty using the language, understanding it. So someone identifies that they have a concern, and then that child is referred to a specialist, and then they wait for an appointment with a speech-language pathologist. Once they have that appointment, if there is a concern and they are diagnosed with a speech or language impairment, then they start intervention. So the work that we're doing through establishing methodologies for clinical AI is to increase community access so that caregivers and the children don't necessarily have to wait as long. So there's immediate risk detection. There is more efficient triaging into clinical health systems and into the referral system, leading to faster diagnosis and ultimately reducing wait time. But there's a lot of work that we have to do to get there. So in our work, where we focus mostly on speech, we need a lot of speech data. And currently, there aren't many speech databases for children that are under the age of 5 years old. So that's what we're focusing on doing, is building up a repository of child speech that we can use to train artificial intelligence models. But as we think about that, we also have to think about doing that in a standardized approach, because many of the databases, the few that are available, people have made decisions on how to collect that data, but we all haven't been talking to each other about it. So there are slight differences. So we're thinking about how we can standardize that approach. We utilize this FAIR data model because when we do collect speech data, we want to make sure that, one, it's findable, so we're doing it in an open science way, that it's accessible by our machines for development of the artificial intelligence technologies, and that it's also reusable, that we can use it in different ways. So we've been working on building up a large speech database of children. We've standardized it so we could get a speech from children across the U.S. So we were able to collect speech out of 8 research sites in the United States, and I'll share kind of the regional locations of that here in just a moment. But before we could deploy across the U.S., we needed to standardize the kind of materials, the training protocols that we utilized, the ways that we would check the quality of that data, all of our recording equipment. We had to secure our data to protect privacy with high ethical considerations. And then we also had a team of speech language pathologists who were also going to be scoring these protocols. So we had to also think of ways of systemizing that as well. So here gives a little glimpse of all of the work that we did to create the standardization protocol. It allowed us to deploy into 8 cities across the United States, representative of 4 dialect regions. And so we wanted to make sure that this data set was rich with diversity of the kinds of people who are talkers. So we wanted the variability of human speech. We started with this diversity in a specific task of having children who are Black, Latine, white, and experiencing poverty, because these are many of the children that we see clinically. So that resulted in us being able to collect this large data set. And so we now do have a new data set that's called the Speech Production Repository for Optimizing Use of FAIR AI Training for our clinical pipelines. So it is quite complicated. We have to consider how we are going to protect this data ethically, how we are going to manage the infrastructure of that data, and then also how we develop it so that it can communicate with machines and be ready for use with AI models. So all of this work culminates in us taking this big step forward towards systems that allow us to collect large amounts of data, to manage that, and to develop ethical standards. And this lays the foundation for clinical AI and early speech disorder detection. Thank you. Take some
Hi.
questions.
Yeah, I'll start with some questions. I think we have maybe some rolling in. But wonderful presentation. Thank you for being the first to step up and do the press conference today. So I wanted to ask about the database. So who do you expect, or are you hoping that will use these tools?
So broadly, we are looking at, there's various kinds of clinical AI that will develop over the next few years. It's rapidly developing. But although we're looking at it specifically in the area of speech communication and disorders, this actually has broad application into education technologies as well, because there's a lot of applications that are using AI for assessment and scoring. So it's important that we understand how child speech impacts these systems. So we're hoping that many people will use it as they are moving forward in assessment of children across even the education sector.
Wonderful, thank you. We have a couple of questions online, which Wendy will take care of.
Thank you. Our first question is from Anashay Bhandari. She asks, since there is so much variability in child speech, how much larger does a data set of child speech need to be than adult speech data sets in order to be widely applicable?
Yeah, this is a great question, and we have lots of conversations with our collaborators in computer science and our data scientists as it relates to what do we need for child speech. Unfortunately, I don't have a great answer for this because when I ask them the same question, they just tell me more. So, what we are aiming for, though, is to have thousands of children in our database. So, our ultimate large goal is to have about 2,000 children that will yield about 1,000 hours of speech, which has been our current recommendation of what we need.
Great, thank you for that. Next question is from Avery Thompson. Avery asks, how important is data quality versus quantity when it comes to training AI?
Yeah, also another really great question. There's a balance between the two, and we actually, when we first started this project, we made decisions to try to collect the speech data in actual school sites, which decreases the quality because of noise in the environment, but also tells us more things about natural communication where children are, versus increasing the quality by then moving some of our work into research sites that were across the United States that were very controlled, quieter rooms. I think we need both because we need to be able to train models that perform with levels of accuracy that we need that from some more ideal settings, but we also do need noisier data from more natural settings as well. So we will have to strike a balance between this as we are developing our technologies.
Thank you. And my last question from the live stream audience is, what was the process behind choosing the demographics behind the people sampled?
Yes. So partly when we are conducting our assessments, so some of the conversations that we have with clinicians is that children that are in preschool environments, the large population, are children who are Black, white, Latine. But also we have children in preschools that are experiencing poverty. So we just made a choice because we wanted to start smaller to have the data set increase in representation, but us also be able to control some of the variability and understanding, because this is a very new space of managing child data, but also the variability that occurs in child speech as well. So we just made decisions to start small, but our hope is as we build the foundation of strong models that can manage child variability, that we will rapidly increase to other languages and other dialect variations that are around the U.S.
Thank you so much. Once again, Marisha, thank you so much for your presentation, and we will move on to the next one.
Thank you so much.